In this example, we're going to calculate how much energy we can get from fusion for a particular situation. The situation I've chosen here is the sun. You've got the sun, which puts out a luminosity of the sun, which is about 3.8 by 10 to the 26 watts. And that's powered by combining hydrogen to form helium. So let's take 4 hydrogen nuclei and produce 1 helium nucleus, and in the process some energy is liberated. So let's ask how many of these reactions we need to power the sun. So how much energy are you going to get? The atomic mass of hydrogen is 1.00794 atomic mass units, whereas helium, so the mass of helium is 4.002602 atomic mass units. So the change in mass is 4 times the mass of hydrogen minus the mass of helium equals 0.029158 U, which if you feed in the atomic mass unit, which is 1.6605 by 10 to the minus 27 kilograms, gives you a whopping 4.84 by 10 to the minus 29 kilograms. So that's the mass difference. How much energy do you get out? Use E equals mc squared. So multiply that by the speed of light squared. Speed of light is 3 by 10 to the 8 meters per second. So it gives us an energy released per one of these reactions of 4.4 by 10 to the minus 12 joules. So pretty small. We can therefore ask how many fusion reactions we need per second to produce the luminosity of the sun. So we just, the number of reactions is just going to be luminosity of the sun divided by the energy per reaction. So it's this divided by that, and that comes out as 8.6 by 10 to the 37 reactions per second. We can therefore work out how much mass we are consuming. The mass of each helium atom produced is that. So multiply that into this, and we find we're using about 5.7 by 10 to the 11 kilograms per second. Sounds like a lot of mass. That's what we need to power the sun. That's how much hydrogen we need to turn into helium. But the mass of the sun is 2 by 10 to the 30 kilograms. So if you divide this into this, you get a lifespan, how long it would take to turn that mass at this rate into helium, and that comes out as about 10 to the 11 years. In fact, the sun will only last about 10 to the 10 years, 10 billion, not 100 billion. The reason is that most of the hydrogen will never be converted into helium. It's only burning hydrogen to helium right in the centre, so maybe the central 10% will be converted, most of it won't be. So that's how you do a fusion calculation.